UTKARSH ASTHANA'S HUB, the Wondertainment Zone. Complete Earthly Timeline. Hi guys, this is UTKARSH M Dollurix and you're watching Hub X-Selective documentary on the complete earthly timeline, from its formation to its eventual destruction. We will cover all topics, that how Earth formed, how life began on it, when did Fuca appeared, when did multicellular life begin, when did global glaciation events occur, when did Leuca appear, when did dinosaurs came into existence, when were primates born, and how they opened the road to the birth of humans on Earth, and then how in the future the planet which gave birth to life becomes dead, meaning the eventual destruction of Earth 5 billion years later. We will talk about all of it. So let's begin. How Earth was formed. The formation of the solar system started 4.567 billion years ago. More than 4.5 billion years ago, the Milky Way galaxy collided with a nearby dwarf galaxy. The encounter hastened the formation of stars. Our solar system is a part of the Milky Way galaxy. Within the solar system, material circulation has been progressing from eternity. This process only gradually and steadily made the water component from the outer region evaporate to make the materials dry. The snow line here shows the dry particles and the wet particles. Through this process, particles were zonally distributed depending on their water content. And with the help of this process, only the bipolar flow stopped, and with it, material circulation also stopped. Some regions around the sun with high particle density appeared as black. Within these regions, collisions frequently occurred. Small particles gradually grew to become planetesimals. Then, slowly and gradually, and eventually, planetesimals continued colliding with smaller particles and other planetesimals, eventually growing to planets such as our home planet, the Earth. And this is how the formation of planets began in our solar system. And that is how our 9 planets of our solar system, including Pluto, were formed. The formation of Earth began 4.56 billion years ago. At that time, the Earth looked like a giant red star. A number of planets were moving in the same orbit, and they all looked more or less the same. The early Earth collided with smaller mass-sized planet, and due to this massive collision, it gave birth to the giant impact 4.55 billion years ago, because of which our natural satellite Moon came into existence. Slowly and gradually, the debris from this impact eventually came to form our Moon, as I said right now. And then, as the Moon was finally formed, the Earth-Moon system as we know it today was finally in place. And then after that, finally, Earth started becoming livable. So as slowly and gradually time passed, countless planetesimals and icy planets bombarded the early dry Earth, which was more of a fireball than being a planet. Due to the bombarding water-enriched planetesimals, the Earth became enveloped by an ocean atmosphere system, which made livability possible on it. The formation of atmosphere and ocean started 4.37 to 4.20 billion years ago. And when we divide the Earth in two halves, we could clearly see that now crust, upper mantle, lower mantle, outer core, inner core, all were formed, and this formed the basic structure of the livable Earth as we know it today. The water vapor in the atmosphere produced rain, forming an ocean. The atmosphere pressure gradually decreased because of the carbonate materials and H2O. as we can clearly see here in this graph. And CO2 levels also began increasing in the atmosphere. Carbon dioxide also combined with rock components and was transported to the bottom of the ocean through weathering and erosion. And this once again proved the livability on Earth. At this time, the ocean was still toxic with high salinity and an overabundance of metals. It was too toxic to support earthly life at that time. Then, after that, the initiation of plate tectonics began 4.37 to 4.20 billion years ago, and because of the plate tectonics, upwelling mantle displaced the oceanic plates above. And because of this only, finally, eventually and gradually, the land and sea became different from each other. The earth, which was once fully water planet, now it also had land on it. Uplift of the plate by mantle convection caused horizontal slippage due to the weight of the plate, and the mid-ocean ridge was formed because of the heavy metal deposits. This is plate tectonics in action, as you can see it right there in the short clip. And because of this only, finally, the oceanic plate subducted under the lighter continental plate, which here you can see clearly. And because of this only, the mountains were formed and they came into existence. Weathered sediments neutralized the ultra-acidic ocean, carbonate materials, heavy metal deposits, CO2, H2O levels rose tremendously, which formed our atmosphere. Heavy metals settled out and became fixed as deposits at the mid-ocean ridge. These deposits were transported through plate tectonics into the deep mantle. And that is how the different layers of earth were formed, which you could see in this cross section. Gradually, the ocean became a habitable environment for marine life, the very first form of earthly life on Earth ever. By 4.2 billion years ago, a liquid core formed in the center of the Earth. Convection with the liquid core created a strong magnetic field surrounding the Earth. Then, because of that, the geometric field shields the Earth's surface from cosmic rays, and Earth's magnetic field came into existence. The Earth's surface was nearing readiness for life, and it was now the beginning of life. How proto-life began on Earth? The early Earth, when the atmosphere prevented sunlight from reaching the surface, was like a red goblin. Primitive life was about to emerge underground in the cave of a geyser, right here as you can see in front of you. And because of this only, finally, an underground cave of natural nuclear reactor was found. Uranium ore emitted large amounts of radiation, creating a diverse range of materials and eventually producing the early building blocks of life, amino acid and ribose, phosphoric acid and nucleobase. Then, after that, finally, water boiled and rose up to the surface, and the surface water flowed back down into the natural nuclear reactor, which made the temperature increase by 20 degrees Celsius. The temperature of the geyser water remained below 100 degrees Celsius, protecting the newly formed biomolecules. The underground environment was reductive, while the surface environment oxidizing. These conditions were necessary to synthesize biomolecules. And then finally, in the Earth's Hadean eon, tidal forces were much more pronounced than they are today. Even lakes had significant ebb and flow of water, creating wet and dry cycles. These wet and dry cycles were one of the most crucial factors in producing the building blocks of life. And that is how finally ribose and fatty acid were formed. Fatty acids grouped together in huge quantities, which resulted into the encasing of the proto-life molecules. And that is how Proto-life began on Earth, finally slowly, steadily and eventually. Then after that, polymerization progressed under the wet and dry cycles. Amino acids and oligopeptides were formed. Eventually, protein-like basic materials that could act as catalysts were produced, because of which only, finally now, these molecules circulated between the geyser cave and the surface environment. The interactions of these materials led to more complex biomolecules being formed. And now here, finally, proto-RNA, a life-encoding molecule, was formed. Proto-RNA combined with enzyme-like basic materials and evolved into ribosomes, which had the ability to replicate themselves. This laid the groundwork for life to reproduce on Earth. And that is how, finally, these molecules were enclosed within lipid membranes, forming primitive protocellular life on Earth for the first time ever. And that led to the birth of first proto-life 4.1 billion years ago. And that is how life began on Earth. Finally, slowly, steadily and eventually. This was the beginning of life. Initial stage of earthly life. The loss of primordial continent and generation of strong geomagnetic field occurred 4.37 to 4.20 billion years ago. The Earth's plate tectonics, which had begun with the creation of its ocean, eventually destroyed its primordial continent Pangaea and subsumed it to the deep mantle, because of which, finally, by 4.0 billion years ago, the mother continent Pangaea had disappeared, leaving life on the margins of a fragmented land mass. And because of this only, the Pangaea was sucked inside the earth, and as it went inside the earth, a dramatic change was about to now begin. Now, as Pangaea was sucked inside the earth, the subducted primordial continent descended towards the core mantle boundary. And because of this only, finally, as the wealth of radioactive elements in the primordial continent Pangaea caused the uppermost part of the core to melt, then because of this only, finally, the primordial continent was sucked inside. By 4.2 billion years ago, the newly created liquid outer core was strengthening the Earth's magnetic field, protecting the surface environment against solar winds and cosmic rays. And that is how Earth's geomagnetic field was formed. As a result, life could now exist on the surface environment. And because of this only, finally, the emergence of sun-powered life began 4.2 billion years ago. The supply of energy and nutrients through material circulation is necessary for life. We all know that. And that is why only the essential mechanism to maintain life is an endless flow of electrons. The first proto-life couldn't survive very far from the nuclear geyser due to the insufficient energy. How did earthly life evolve? Mutations were the hope. They allowed life to evolve on Earth. And because of them only, the more resilient life forms were able to adapt and survive in harsh environments, hence survival of the fittest. This second stage of proto-life evolved to make use of the sunlight available on the Earth's surface. And hence, because of this only, finally, they developed a metabolism that converted light energy into electrochemical energy, some way which is very similar to the modern day photosynthesis process used by the plants. Moreover, they use sugars to store energy for the sunless night hours. Sugar was converted to amino acid and vice versa. The source of energy for life on Earth shifted from nuclear geysers to the sun, which was a real revolutionary evolution. And because of this only, sun became the real powerhouse for Earth. The mass extinction occurred 4.1 billion years ago. It was a huge destruction. Almost all of the Earth was destroyed, but that only marked the beginning of new life. The ocean was still extremely toxic, killing off most of the proto-life forms within it, which was not good. Nevertheless, some proto-life forms survived the extreme environment, and those who survived were the real heroes. These were those who developed protective mechanisms to prevent the metallic ions into the oceanic water from entering their protocells. And once again, they were the fittest and hence they survived. This proto-life began coalescing into larger and more complex forms. Modern life forms use only 20 kinds of amino acids. This means our ancestors that used the same amino acids were the ones that survived the mass extinction. Evolution walks a perilous tightrope between continuing and ending. Unstable RNA evolved through ionizing radiation into more durable DNA, making it possible to reliably pass information across generations. And finally, that is how the third stage of proto-life was born. This was the beginning of prokaryotic organisms, the ancestors of today's archaea and bacteria. Progressive stage of earthly life. The emergence of photosynthetic life began 2.9 billion years ago. Oxygen, when unbound to any other material, can be toxic to life because oxygen destroys the reductive life body. And that is why only, therefore, the first photosynthetic organisms would have been anaerobic microbes which produce no oxygen or O2. Life, however, adapted taking advantage of oxygen or O2, and it acted as a valuable source of additional energy. Slowly and gradually, the development resulted in the appearance of cyanobacteria. Which then afterwards produce oxygen, which crystallize into felsic iron bearing oxide, reducing the iron content of the ocean. Still, the ocean was 5 times as saline as it is today, which means it was still unlivable and extremely toxic. The mantle overturn took place 2.7 billion years ago. As the Earth's interior cooled down, old slabs of the primordial crust resting at the bottom of the upper mantle fell into the lower mantle, hence now resting on the boundaries of the outer core of Earth. Now that was a major change in the structural layers of Earth. Meanwhile, numerous mantle plumes ascended from the lower mantle into the upper mantle. This phenomenon is known as mantle overturn. Mantle plumes push the basaltic crust upward, generating landmass. This gave birth to the mighty volcanoes, and that is how they were formed. Because this created shallow muddy environments penetrated by sunlight, which allowed the cyanobacteria to flourish. and the oxygen produced by the cyanobacteria gradually altered the Earth's atmosphere. On the ocean floor, ferric and ferrous iron were accumulating in the form of hematite and magnetite, creating a massive banded iron formation. By 2.5 billion years ago, the remaining banded iron of ferrous formations was a few kilometers thick. This rapid decrease in iron content changed the color of ocean to a familiar blue as we know it today, and because of this only Earth's other name is Blue Planet. Life began to change the surface environment such as the co-evolution of the Earth and its inhabitants, the Earthlings. This was an important step in the life of Earth's journey towards civilization, and that is how earthly life became fully developed, and hence began the developed stage of earthly life. Mass extinction by snowball Earth event occurred 2.3 billion years ago. A collision between the Milky Way galaxy and a nearby dwarf galaxy produced countless glowing stars, just like our very sun. Within a few thousand years, some of these stars ended in supernova explosions, and a myriad of cosmic rays from the supernova deteriorated the sun's heliosphere and bombarded the Earth. These cosmic rays helped generate cloud condensation nuclei which produced more and more clouds until the Earth was completely blanketed with them and looked like a white snowball. The thick cloud cover prevented sunlight from reaching the surface of the Earth, and as a result of which the Earth underwent a global glaciation event known as the Snowball Earth event. This caused another global mass extinction. But once again, some life survived yet another difficult period beneath the ice sheet. Once again, the fittest survived. And because of this, as a result of this, tiny life was protected by Earth's massive circulating system. And the Earth is similarly held in place by the solar system and the expansive universe at a greater front. Life is but one part of an enormous system. As time passed, the clouds layer disintegrated and the blue planet was right there in front of us. A transition from prokaryotes to eukaryotes happened 2.1 billion years ago. The prokaryotes survived the snowball Earth glaciation event, evolving into more complex life such as the endosymbiotic systems living together inside cells. They formed mitochondria and chloroplasts, which allowed them to get more energy from oxygen or O2. A single prokaryote body could contain thousands of mitochondria, the powerhouse of the cell, inside it. A nuclear membrane formed protecting DNA from the oxygen-dense oceanic water. DNA strands grew longer, retaining ever more genetic information inside them. Life evolved into more diverse and complex organisms. And that is where Fuca came into existence. It was the first universal common ancestor. At long last, the eukaryotes appeared. The eukaryotes grew 1,000,000 times larger than the prokaryotes. In theory, everything inevitably falls into disorder. And yet, life is orderly and increasingly complex. Life seems to continue evolving, undeterred by universal entropy. And that is how life is actually. Marine life comes into existence. Formation of Nuna supercontinent occurs 1.9 to 0.8 billion years ago. Plate tectonics caused small developing continents to assemble into a single supercontinent called Nuna. As Nuna formed, its burgeoning landmass provided cyanobacteria with an expanding habitat in its lakes, rivers, wetlands, and estuaries. Cyanobacteria became really important for the marine life. Cyanobacteria produces free oxygen through photosynthesis process, the same process which is used by plants so as to obtain food and to make it. At that time, however, most of the free oxygen produced was consumed in decomposing dead cyanobacteria, so very less or little free oxygen accumulated in the atmosphere. On land, however, dead cyanobacteria got buried under sediments. So oxygen that would have broken down their bodies instead ended up in the atmosphere. The presence of a large landmass helped increase the amount of oxygen in the atmosphere. As the total land area on the surface of the earth increased, so too did atmospheric oxygen levels dramatically. Over the time, the Nuna supercontinent broke up into smaller continents. But once again, plate tectonics reassembled a supercontinent, this one called Rodinia, in the equator region. Slabs of oceanic plates subducted under continental plates gradually accumulated in the mantle transition zone. Eventually, these slabs fell down into the core. The slabs cooled the outer core, changing the flow of electricity within. This electricity is known as geoelectricity. As a result, the core's dipole magnetic field transformed into a weaker quadrupole magnetic field. The Sturtium glaciation occurred 700 to 600 million years ago. The Milky Way galaxy collided with a dwarf galaxy and underwent a transition into starburst conditions. Over time, these newly produced stars ended in supernova explosions, bombarded the Earth with cosmic rays. The Earth, with its weak quadrupole magnetic field, was heavily affected. Clouds covered the entire Earth and ice covered its surface. A series of supernova explosions occurred. Long periods of extreme heat were punctuated by shorter extreme cold. In the extremely cold periods, oxygen in the atmosphere fell to Archean eon levels, causing mass extinctions. These mass extinctions, however, created great opportunities for life to evolve into something completely new. Repeated influxes of cosmic rays and drastic fluctuations in oxygen levels. These environmental changes caused genetic mutations that accelerated the appearance of new species. The leaking Earth phenomenon takes place 700 to 600 million years ago. The starburst period ended and the Earth's core reverted to a stronger dipole magnetic field. Ongoing photosynthesis returned the oxygen in the atmosphere to previous normal standard levels. Meanwhile, the inner Earth was gradually cooling down. When the inner Earth is hot enough, the components of water trapped in minerals in the oceanic layers are released to the surface environment, as we can clearly see here, and the seawater level is unaffected. However, once the mantle temperature drops below 650 degrees Celsius, minerals carry these water components down into the upper mantle. Meanwhile, on the surface, deprived of the components of water, sea levels gradually decrease. This is known as the leaking Earth phenomenon, which is inevitable on a cooling planet like Earth, which is cooling down. This leaking effect moved 3% of all seawater into the deeper mantle. Sea level dropped by 600 meters, as we can clearly see in the elevation distribution graph right here. As a result, surface land areas grew, as did continental shelf areas receiving sunlight. A habitat for future life on Earth was being created. Rivers carried nutrients from the inlands down to the continental shelves, and the additional landmass significantly accelerated the buildup of oxygen into the atmosphere. These processes set the stage for an explosive evolution of life forms. Cambrian explosion occurs and new earthly life begins. The origin of multicellular life begins 640 million years ago during the Marinoan glaciation. Extreme climate changes continued, putting life on a path to new evolutionary stages for survival. Life evolved with prokaryotes and eukaryotes living together as ever larger symbiotic organisms, compensating for each other's shortcomings and thriving as a whole. This greatly expanded the possibilities for forms of life, and this was the proof of the first symbiotic relationship ever. Sponges was a good example of this. Life forms grew to 1 million times the size of eukaryotes and 1 trillion times the size of prokaryotes. The appearance of multicellular life was critical leap for evolution. Leuca, last universal common ancestor, comes in place. The appearance of Ediacaran fauna and the gaseous glaciation took place 580 million years ago. Another glaciation period came and life suffered a mass extinction. With time, this glaciation also passed and the global climate gradually warmed. Phosphorus and other materials essential for life circulated through the climate systems and accumulated in the oceans on the oceanic floor. The animals of the Ediacaran period appeared at this time. Dickinsonia are iconic among the Ediacaran fauna. Some grew to over 1 meter in length. They were soft-bodied creatures with no shell or skeleton. Dickinsonias were large muscular pieces. They probably lived in warm, shallow marine environments around the Rodinia supercontinent. Evolution responds to environmental changes 550 million years ago. The supply of nutrients from the land was ever increasing, as was atmospheric oxygen. The amount of ferrous iron in the oceans increased. The ferrous iron oxidized, once again creating large bands of iron. Phosphorus and calcium levels in the ocean increased. Life evolved to use these elements, becoming animals with bones and shells. That is where microdictyon comes in place. For example, the calcium helped it to protect from other animals. Their bodies use calcium to form a covering of hard scales. Life evolves to survive, making use of the elements in its environment. And the Earth's environment alters the shapes of life. The first Cambrian organisms come in existence and the Baikonur glaciation takes place 540 million years ago. The Earth entered another period of climatic instability. The Earth alternated between periods of extreme heat and extreme cold for tens of millions of years. These severe changes killed off the Ediacaran fauna. Nevertheless, new species were about to appear. This was the time of real evolution for earthly life. Radiation from inside the Earth plays a significant role in the evolution of life on Earth. A continental rift is a place where a continent breaks open to expose erupting magma and radioactive elements. Radiation hastens the creation of new species and new branches in the tree of life. Suppose this is a species A and this is a species B. With the help of stem evolution, new species creations can take place at continental rifts. Life evolved separately on each small continent. When small continents recombined, their life forms crossbred. Different crossbreedings created new forms of life, variations thrived. This was the crown evolution. Continental collisions created more diverse surface environments. Bays and gulfs on large continents were especially well supplied with nutrients from upstream. Making use of these nutrients, Cambrian era, life forms diversified much more quickly. The Cambrian explosion created some 35 new phyla. These phyla became the foundation for the types of plants and animals we see today. There are three main ways that life evolved. Mass extinctions that eradicated many species, stem evolution that hastened genetic mutations when continents broke apart, and crown evolution that hastened biodiversification when continents collided. So the evolution of life is inextricably linked to environmental changes due to universal factors and continents assembling together and breaking apart. The habitat started to expand 600 million years ago. The ocean was more than 5 times as saline as it is today. 600 million years ago, the ocean gradually became less salty. Salt from seawater was relocated to the land in the form of rock salt. Decreasing sea levels made this possible through more exposed land. Even if seawater rose again high enough to reclaim the rock salt, most of it had become inaccessible, encased in sediments. The decrease in seawater salinity made the ocean more hospitable to diverse life forms. Estuaries and open seas welcomed new life. With increasing atmospheric oxygen levels, an ozone layer formed in the Earth's upper atmosphere. The ozone layer absorbs ultraviolet radiation from the sun. The land was becoming a more habitable environment. And then the coevolution of plants and insects started 540 million years ago. Algae was the first life form to transition out of the water onto the challenging land environment. This is why algae evolved before animals did. When insects appeared, they co-evolved together with the plants. The evolution of vertebrates started 550 to 540 million years ago. Appearing during the Cambrian explosion, fish were the first of the vertebrate animals with backbones. Fish are the oldest vertebrate ancestors of us humans. As fish continued to evolve, Ichthyostega appeared, the ancestor of amphibians. Plants flourished, producing free oxygen through photosynthesis, providing the atmosphere with 1.5 times as much oxygen as it has today. Long after, the remains of these plants would become sedimentary coal. That coal would help fuel the remarkable breakthroughs for human civilization that started with the Industrial Revolution. Next, vertebrates equipped with lungs appeared and made their way onto land. And that is how the life on land started on Earth. The tree of life evolved, branching from fish to amphibians to reptiles and then dinosaurs and mammals, and eventually to us humans. This guy hasn't found about all that just yet. Due to collision with nebula, mass extinction occurs 260 to 250 million years ago. The solar system collided with a dark nebula. As the solar system passed through the nebula, the Earth was bombarded with cosmic rays. The Earth entered yet another frozen age. Plants were affected first, dramatically reducing the oxygen they supply to the atmosphere. The surface environment reverted to an anaerobic state like during the Archean period. The lack of oxygen killed off most species of amphibians, reptiles, and insects. Life managed to continue evolving, but faced another big challenge. Untouched by the evolutionary changes on the Earth's surface, anaerobic microorganisms had been thriving in oxygen-poor underground environments. The new oxygen-poor surface environment allowed them to re-emerge on land and in oceans. Their native habitat expanded across the globe. As oxygen levels rose again, these microorganisms evolved to adapt to the new environmental conditions, setting the stage for another phase of evolution. The emergence of new creatures that would evolve into humans was close at hand. The age of dinosaurs began. Dispersion and amalgamation of continents and the evolution of life. On the supercontinent Laurasia, mammals and reptiles appeared and started evolving under a warm climate. While reptiles diversified into many varieties, mammals remained nocturnal, rat-sized animals. The mammals were in the shadows. Edalobacillus, a small rat-sized animal, was the first mammal born on Earth and hence it was our most ancient ancestor. With the appearance of dinosaurs, reptile entered a golden age. Dinosaurs prevailed against many other animals and won the struggle for survival. Eoraptor was amongst the first dinosaurs born on Earth ever. High R magma is produced when a continent is split apart, and this is where stem evolution occurs due to induced mutation. Dinosaurs were at the pinnacle of their ecosystems. They improved and evolved further, and once born, now they ruled the earth. The pieces of northern Laurasia that had split later rejoined. This caused crown evolution, a very major step in the evolution of earthly life. Amalgamation of continents brings the hybridization of life, and new species spread out to other continents. The Tyrannosaurus rex was born. Dinosaurs flourished all over the world. In the plant world, angiosperms with advanced reproductive capacities appeared. Angiosperms utilize animals to help with pollination and thus flourished. On the other hand, the appetite of gymnosperms was reduced. The road to birth of humans begins, the birth of primates. Primates, the ancestors of humans, appeared at a rift of the Gondwana supercontinent. By a stem evolution, new species appeared among the rodents such as rats. They were known as Plesiadapis. They are the most ancient ancestors of primates known till date. With time, Gondwana split into South America and Africa. After South America was isolated, the primates there evolved into the New World monkeys. On the African continent, the primates evolved into the Old World monkeys. That is how two species of monkeys was formed. After the Indian subcontinent split off from Antarctica, primates on this continent evolved into lorises. Primates evolved independently on each continent, and in this way many species of primates appeared. When we split Earth into two halves, a large-scale Pacific superplume pushed the Pacific plate up and raised the sea level. We can clearly see that here. Lowlands fell below sea level and the total land area decreased. Rising sea levels segmented the continent, providing isolated environments for individualized morphological evolution. Xenarthra, Afrotheria and Borotheria were three such environments. A universe-scale event had changed Earth's surface environment. The solar system collided with a dark nebula. The Earth was entirely covered by clouds and looked like a snowball once again. Global glaciation occurred once again, and as the global cooling progressed, catastrophically damaging ecosystems, many dinosaurs died due to this. Then, finally, a meteoroid 10 km across fell on the Yucatan Peninsula. This event was the final trigger to cause the mass extinction of dinosaurs, those rulers who ruled the earth for 740 million years. The fate of the earth's life is deeply connected to the events in the universe. Universe-scale events can cause global cooling and mass extinctions. Moreover, galactic cosmic rays directly affect the DNA that carries the blueprints of life. Cosmic rays cause mutations which promote evolution. All aspects of life on the earth are thus influenced by universe-scale events. Once again, global glaciation happened. Finally, the dinosaurs that had once flourished now went extinct. evolution into primates happened. Along the African Rift Valley, explosive volcanic activity continued, and peculiar magma containing abundant radioactive elements erupted. Old world monkeys, a new clade of primates, appeared there. They are thought to be our remote ancestors. Birth of humans. The Humanozoic Eon, the birth of human beings, the fourth animal category. About 4.5 billion years have passed since the birth of the Earth. Large fluctuations in terrestrial environments have occurred repeatedly. A never-ending cycle of life and death. Finally, human beings appeared. This was the onset of the Humanozoic Eon. Humans have a unique set of genetic regions called human accelerated regions or HARs, and these regions differentiate humans from other animals. Humans develop enlarged brains that enable them to gain language capabilities. They also gain the abilities to think, to be conscious, to remember, and to imagine. Here you can see in this graph the stepwise increase of human brain volume. The brain volume of human beings has discontinuously increased in 3 stages. The growth of the brain volume seems to be synchronized with large-scale volcanic eruptions. This indicates that the increase in brain volumes is caused by stem evolution driven by high R magma. About 12 lakh years ago, humans started moving out of the African continent. The last common female ancestor who left the African continent 2 lakh years ago is called mitochondrial Eve. Descendants of mitochondrial Eve entered North America and Central America 15,000 years ago. 10,000 years ago, further descendants reached the southern tip of South America. They had spread all over the world. Since then, an epochal advance of human civilization has taken place. Advancement of human civilization. The agricultural revolution started 10,000 years ago. Humans invented agriculture and livestock production. With these methods, a stable food supply became possible. Human populations increased rapidly. The Egyptian civilization is a good example of agricultural revolution. The urban revolution started 5,000 years ago. Various occupational specializations arose, people began to barter and trade. The Mesopotamian civilization is a good example of urban revolution. To enable effective bartering, cities formed. With time, small cities developed into small city-states with currencies, economies, laws, courts, and policies. Indus Valley civilization is a good example of city development. Yellow River civilization was amongst the 4 great civilizations of the world which appeared along large rivers, where food productivity is higher than in other regions. The religious revolution started 2,400 years ago. Conflicts and fighting over territory occurred between civilizations. To avoid fighting, religion spread to replace governance by royal families entrenched through inheritance. With time, national leaders came to be elected by voters. Modern democratic nations appeared. Democracy is the social form that grants freedom, equality, and basic human rights. The Industrial Revolution began 300 years ago in Great Britain after Principia by Isaac Newton was published. New technologies established or applied based on scientific knowledge dramatically changed human society. The invention of the steam locomotive enabled transportation of goods by railway. The invention of cars and airplanes enabled us to travel long distances easily. Human society entered the age of never before seen abundance. However, war occurred incessantly. Sometimes irreversible tragedy was caused by the misapplication of scientific knowledge. Good example of this is the atom bomb. The information revolution arose following the invention of computers and the invention of the internet led to a new era in which people across the world can connect with each other in an instant. Out of contrition over past wars, the birth of a unified world nation is coming to be realized. In 1993, the EU was formed as a unified state in Europe where wars had recurred most frequently. In other areas, similar federations have been emerging, bringing us closer to the birth of a unified world nation or a supernation. Within the scope of Earth's history, the Humanozoic era is very short in compared to others. However, it is humans' entire history unfolding within the context of Earth's history. Biologically, humans are just one species of animals. However, we are essentially different from other animals because of our evolved brains. What else lies ahead for human beings? That we have to find out. Future of humans on Earth. In the field of science, innovative technologies will be developed at an accelerated pace. Humans will build a space base on the moon to prepare for exploration of our solar system's planets. Artificially intelligent robots will be involved in space exploration, assisting humans in their tasks. In the near future, self-replicating robots will appear and will evolve beyond humans' limits. These artificial life forms will gradually travel out into the galaxy. Moreover, new technology enabling us to go into different dimensions will be developed. Humans must become able to recognize the world beyond space and time. Eventually, the role of human beings will be finished. This will mark the end of reign of humans on Earth. That will be the end of the Humanozoic era, which lasted for 0.3 million years. This scenario may be the inevitable result of the strategy of life's evolution. Because in the future, the Earth will face more upheavals than ever before in its history, ever. Future of the Earth. Formation of a supercontinent will take place 200 million years later. Centering on Asia, all the continents will gather together to form the supercontinent Amasia. Extinction of C4 plants will happen 400 million years later. Plants consume atmospheric CO2 to fix carbon within their bodies. Dead plants made of fixed carbon are covered by sediment. This process plays a role in reducing atmospheric CO2. The appearance of the supercontinent Amasia will lead to an increase in the land area that can fix carbon. More plants on a larger supercontinent reduce more atmospheric CO2. The amount of CO2 will decrease to 1/10 of the present level. The C4 plants requiring higher concentration of CO2 will go extinct. As a result, other animals that rely on the C4 plants for food will be affected. Cessation of plate tectonics will take place 1 billion years later. Seawater has been decreasing for the past 600 million years as it has been transported into the mantle in the form of hydrous minerals. Finally, mid-oceanic ridges form summits above the seawater. Water cannot be taken into the crust as a lubricant anymore and plate tectonics is terminated. This is the fate of a cooling planet, like Earth. Volcanic activity along the subduction zone stops. Upheaval of the mountain stops. The Earth suffers severe environmental changes due to erosion. Here in this cross-section view of Earth, you can clearly see that subducted cold plates do not go down to the bottom of the mantle. The outer core is not cooled down anymore and the geomagnetic field disappears from Earth. Hence, Earth loses its gravity. Earth's atmosphere is removed by the solar wind. At this point in time, large multicellular animals living in the surface environment go extinct. The oceans disappear 1.5 billion years later. When the ocean disappears, animals that survived in the ocean will also die. Finally, all the Earth's life disappears. The heating up of the solar surfaces increased the Earth's surface temperatures to 500 degrees Celsius. The Earth becomes a Venus-like planet. A collision between the Milky Way galaxy and the Andromeda galaxy takes place 4.5 billion years later. The Andromeda galaxy collides with the Milky Way galaxy. Because of this collision, the birth rate of stars increases. With time, those stars undergo supernova explosions. Intense galactic cosmic rays rain on the Earth. The Earth's annihilation will take place 8 billion years later. The expanding sun will swallow the Earth. This is the day when the planet Earth that gave birth to life will disappear from the universe. That will be the day of end of mighty Earth. By that time, Earth's life will have reached other galaxies as self-replicating artificial life in a different form, and hence Earth's journey will end. So hope you guys liked this yet another Wondertaining Hub X-Selective documentary with me, UTKARSH M exclusively at Hub the Wondertainment Zone. If really, then do please click on like, subscribe, share this video with your friends, and stay tuned on Hub the Wondertainment Zone for more amazing Wondertaining Hub X-Selective documentaries just like this one. Also follow us on our Instagram handle UTKARSH ASTHANA'S HUB .co_Insta for amazing sneak peeks and technical insights of our upcoming Hub videos on our YouTube channel UTKARSH ASTHANA'S HUB the Wondertainment Zone. This is UTKARSH M signing off. I will meet you on the next one. Till then, bye bye and adios. Yo. Thanks for watching. Follow us on our Instagram handle UTKARSH ASTHANA'S HUB .co_Insta for amazing, Wondertaining and intuitive technical insights and sneak peeks of our upcoming Hub videos on our YouTube channel UTKARSH ASTHANA'S HUB the Wondertainment Zone. Download the Software Hub app today.